Hey everyone, hope you're doing well. Alright. Quick question. Be honest. How many binary explain videos have you watched already? 2? 3? Maybe more? And if I asked you right now, to explain to a friend why computers use only ones and zeros, you'd probably pause, stumble a bit, and then say something like, that's just how computers work? Yeah. That's not your fault. Because most of those videos? They show you something like 01001000, say this is binary, and then just move on. They never tell you the real reason. Like, why does your phone, your laptop, your smart TV, why does literally everything run on just 2 states? That's the part that actually makes it click. So forget the surface level stuff. Tonight, we're going deeper. Peek inside the machine deeper. And I promise you, by the end of this, you'll understand binary better than most people who've been using computers for years. Let's get into it. Okay, first thing. And this is where everything starts to make sense. Binary is not a programming language. It's not something engineers just made up one day because it looked clean or simple. Binary exists because of a physical limitation. Yeah. Actual physics. Think about the light switch in your room. Right now. What can it do? It's either on or off. That's it. There's no kind of on. No in between. Unless you install something special, it's just 2 states. Now here's the key idea. That switch? That's basically what a computer is built on. Inside your CPU, there are billions, literally billions, of tiny switches. They're called transistors. And each one can only tell one thing. Is there electricity here? Or not? That's it. Now you might be thinking, okay, but why not more states? Why not 5 levels? Or 10, like our number system? Good question. Here's the problem. Electricity is messy. It's not clean and perfect like numbers on paper. Voltage fluctuates. There's noise. Tiny disturbances everywhere. So imagine you tried to build a system where low voltage equals 1. Slightly higher equals 2. Medium equals 3. High equals 4. Very high equals 5. Sounds nice in theory, right? But in reality? A tiny fluctuation. And suddenly your 3 becomes a 4. Your data gets corrupted. Things break. Now compare that to just 2 states. Definitely off. And definitely on. There's a big gap between them. So even if there's noise, the system still knows what's what. It's reliable. And that's the whole point. Binary isn't a choice. It's survival. Now that you get why binary exists, let's actually understand how it works. And don't worry, we're not doing this in a boring textbook way. We're building it together. So think about normal numbers. 247. You already understand this without thinking. That 2 isn't just a 2. It's 2 times 100. The 4 is 4 times 10. The 7 is 7 times 1. Each position has a value. Right? Binary works the exact same way. Just with one twist. Instead of powers of 10, it uses powers of 2. So the positions go like this. 1, 2, 4, 8, 16, 32. Each step just doubles. That's it. Let's try 1. Take the binary number, 1011. Don't overthink it. Just follow me. Start from the right, that's the 1's place. There's a 1, so that's 1. Next is the 2's place. Another 1, that's 2. Next is the 4's place. There's a 0, so nothing. Last is the 8's place. There's a 1, that's 8. Now just add it. 8 plus 0 plus 2 plus 1 equals 11. That's it. You just converted binary to a normal number. No magic. No tricks. Just adding. Here's a way to really feel this. Imagine a highway. And along the highway, there are toll booths. Each booth can either be open or closed. If it's open, cars go through. If it's closed, nothing passes. Now imagine each booth represents a value. 1, 2, 4, 8. The pattern of which booths are open tells you a number. That's exactly what your computer is doing. Except instead of toll booths, it's transistors. And instead of cars, it's electrical signals. And this isn't happening slowly. This is happening billions of times every second. And here's the part that blows most people's minds. This isn't just numbers. Everything is binary. Your text messages? Binary. The color of that red button on your screen? Binary. Your voice recordings? Binary. Even videos, music, games, all of it. Same foundation. Different interpretation. It's like one language being used to tell infinite stories. Now let's go one level deeper. Because this is where things get really interesting. First thing. Programmers don't actually sit around staring at long strings of ones and zeros. That would be a nightmare. So they use something called hexadecimal. Sounds fancy, but it's actually simple. It's just base 16 instead of base 2. Here's the cool part, one hex digit equals exactly 4 binary digits. So instead of writing 10,101,111 you can compress it into just 2 hex characters. That's why you see color codes like #FF5733 that's not random. It's just binary. In a shorter, human-friendly form. Second thing. This one's wild. Computers don't really subtract. Yeah. At the hardware level, they mostly just add. So how do they handle negative numbers? They use something called 2's complement. Don't let the name scare you. Think of it like this, instead of doing 10 minus 5, the computer rewrites it as 10 plus -5. And it has a clever way of representing -5 in binary. So everything becomes addition. It's like a shortcut that simplifies the whole system. Third thing. There's a silent guardian inside your devices. Something almost nobody talks about. It's called a parity bit. Remember how we said electricity is messy? Sometimes a bit flips by accident. A1 becomes a 0. Data gets corrupted. So engineers added a tiny safety check. An extra bit that acts like a quick sanity check. Like, hey, does this data still look correct? If not, it flags an error. This is happening constantly in your RAM, your Wi-Fi, your storage. And you never even notice. So let's wrap this up. No sugarcoating. Binary is not complicated. At all. It's actually one of the simplest ideas in computing. 2 states. Patterns. That's it. What is complicated is how it's taught. Most explanations either oversimplify it so much that it becomes meaningless, or they drown you in theory before explaining the why. But the truth? It's just physics, solved in a smart way. Reliable signals, arranged in patterns, representing everything. And now here's the real question. If something this simple can feel so confusing, what else have we been taught in a way that made it seem harder than it actually is? And more importantly, is that bad teaching? Or is it intentional? Think about that. And tell me what you honestly believe. If you found this video helpful, hit like and subscribe to IQ Tech Nova for more tech tips.